Okay, so this first one, what constitutes an acid under the Arrhenius acid-base theory?
Something that produces hydrogen ions
So anything that increases the hydrogen ion concentration in water is an acid. And a substance that increases hydroxide ion concentration in water is a base. It's very important that when we're talking about that particular definition, that we're talking about water specifically. What's going on? This thing is freezing or something or other. I'm not sure what's going on. All right, how about the Bronson-Lowry acid?
concentration of ammonium ion or hydrogen ion.
Nope. Nope.
Something that donates a hydrogen.
Proton donator, right? Anything that accepts a proton is a base, and anything that donates a proton is an acid. What about Lewis?
Can I ask a question about those?
Sure.
Does that have to be an aqueous solution? Is that something important for that or not?
Yeah, you could say in water. That wouldn't be a bad thing to include. And how about Lewis?
To be
They accept and donate electrons to form a bond. This thing's driving me crazy. So what was wrong with the Arrhenius' theory that we needed these two other definitions?
water.
You don't need water. And what else? Anything else? There's no H plus floating around in any waters ever. That's a hydronium ion. What's the reason nitrogen is considered a base?
It likes to
Should have a big old sign on top of it that says "Form a bond with me," because that's what those two lone pairs of electrons on top of the nitrogen are doing. Okay, acetic acid, yeah, all right. So which one of these is the acidic one?
Connected to the oxygen.
The one connected to the oxygen for sure. Another way you can think about it is which one of these is not like the other. So if it was one of those ones on the left, which one would you pick? There isn't anything to pick, so you can't pick any single one of them, so you don't get to pick any of them. So concentrated hydrochloric acid is 12.1 molar, and so I want to make 750 milliliters, and so I need M1V1, M2V2. So really all I need is V1. So it's going to be 2 molar times 750 milliliters divided by my 12.1 molar. Somebody have a number? 12 and a half?
I think it's 125.
125? Okay.
And that's I use 12 molar because that's what it said in our notes.
That's fine, yeah, okay. Yeah. So put 125 milliliters in a 750 milliliter vol flask, fill near the line, fill to the line with a dropper, something like that. All right, how about this next one?
Potassium nitrate, H2O.
Yeah, I was wondering if this is kind of a trick question because the milliliters and the molar, but they're the same.
Yep, they're the same. So I've got 2 molar of each and 10 milliliters of each, so they just cancel each other out, right? So I'm gonna have 2 molar of this stuff over here, right? You can't really say 2 molar because water, that's not the only water that's there.
Right.
There's other water. Um, So that's the chemical reaction you're going to get out of this. But what happens when I mix these guys together?
The sodium and the nitrate.
Both take up equal amounts. There's 1.33 molar each.
So you could have done some math to calculate out moles and whatnot, but something easier to do is when these react, it takes one of each of them, right? One NaOH and one nitric acid. So if I've got 10 milliliters of 2 molar and 5 milliliters of 4 molar, what does that tell you about the number of actual particles in each of those substances?
There's more
It's the same amount of particles, right? I have it's twice as concentrated in the nitric acid, but I have half as much, so then they're going to be equal to each other, equal to another solution with half the concentration and double the volume. So when I mix these guys together, what am I going to, acidic, basic, or neutral? It's going to be neutral, right? They'll just go ahead and cancel each other out. Okay.
So I have a question about that.
Sure.